1.5 seconds
Yeah,
or
so
so
yes,
of
we'll
video
get the
capture.
exact moment of impact, so measure the exact moment.
But sometimes, for me, I find it helpful to kind of think about the bookends. Like if you imagine a product that never fails, right? That just doesn't fail.
Yep.
And on the other end, a product that maybe isn't very reliable, but is super easy to repair.
Right.
A product that never fails is obviously better for the customer. It's better for the environment.
Okay, it's interesting you put it that way, because on one end you have the product that never fails.
Uh-huh.
On the other hand, you have the product that can be replaced infinitely, but it's not as reliable.
Yep.
That downside of being not as reliable comes from being infinitely repairable. But I think some would argue that the downside of being really hard to repair comes from being almost infinitely durable.
Sure, but they're not always mutually exclusive. Like those are kind of the bookends. So let me give you like a couple of examples.
Yeah.
I think of battery on an iPhone as being an important one. On an iPhone, on any phone, a battery is something, if you want to extend the life of the product, that's something that's going to need to be replaced, right? Batteries wear out. But as we've been making iPhones for a long time, in the early days, one of the most common types of failures was water ingress, right? Yep. Where you drop it in the pool, or you spill your drink on it, and the unit fails. And so we've been making strides over all those years to get better and better and better in terms of minimizing those failures. And I don't know how many years it's been now, but we got to a point of IP68, which is kind of a rating for water ingress, which is really impressive. And I think you get to see some of these tests, right?
Yep.
It's great because we get these stories of people, literally, I dropped my phone in the lake, I couldn't get it for 2 weeks, I fished it out, it still works, they're super excited. That said, to get the product there, you've got to design a lot of seals, adhesives, other things to make it perform that way, which makes it a little harder to do that battery repair.
Right.
You still need to do the battery repair, so we need to make sure we have solutions for customers to do that, which we do. But it's objectively better for the customer to have that reliability. And it's ultimately better for the planet because the failure rates since we got to that point have just dropped. They've plummeted, right? The number of repairs that need to happen. And every time you're doing a repair, you're bringing in new materials, to replace whatever broke. Yeah. So you can actually do the math and figure out there's a threshold at which if I can make it this durable, then it's better to have it a little bit harder to repair because it's going to net out ahead. And so what we had to develop, and teams have been working on for a couple of years, is the ability to, after a repair, the device can go to the secure cloud and pull down the calibration data for that specific display and ambient light sensor.
Okay.
So before, if you did a repair with a brand new replacement part from us, you get that full, perfect True Tone performance. Now you'll get that if you transfer one of these used parts over because you can actually pull the calibration data for that part.
So it's individual things like True Tone or just display calibration, camera calibration maybe.
Totally.
So I got to see a bunch of these interesting machines and labs tests walking around today, which are really cool.
Yeah.
From the IP testing to just like taking up the heat testing and microphone and sensor testing. How do you connect the dots between all of the labs you have here and the real world where, as you know, customers tend to find new ways to test their devices? Like how do you connect those dots?
Well, in large part, a bunch of really talented people who are really good at doing that, kind of understanding failure mechanisms and understanding statistics and understanding how to correlate from a lab test to the field. A lot of this has been an evolution over many years of building products, many years of building iPhones. We learn. And so as you saw some of those tests, in development of any product, right? But take an iPhone for an example. We test thousands. We probably test 10,000 of any given iPhone before we actually ship it.
10,000 different iPhones
Like
before you
10,000 devices of a particular model before we ship it, right? Thousands
Yeah.
and thousands of them through the testing you saw. Water ingress test, drop test, thermal cycling, all of these things. And that test suite, which is a big suite of all these different tests, we've been building and growing over the years based on things we've either found in our own testing, we've found when we'll pull units back from the field and we'll find things and we'll figure out how do we build a test that represents maybe this new use case that somebody's doing in the field. And then that becomes a part of our test suite.